This is going to be a demonstration of series resonance. I've got a variable voltage AC power supply here, a little bathroom vent fan, got a capacitor hooked up in series with it. Then I've got 3 meters. The meter on the left shows the overall voltage coming from the power supply. The red meter in the middle shows the voltage across the capacitor, and the red meter on the right shows the voltage across the motor. And again, the motor and the capacitor are in series. This isn't the normal way we would hook something like this up, but it does demonstrate what happens in the utility line of our work when we have underground high voltage cables, shielded cables, feeding a pad mounted transformer. And we get into an odd situation if one of the primary overcurrent devices would open up. And in the case of a pad mount transformer, the thing will actually start to howl and sound like it's going to come right off the ground. I can't quite do that with this setup, but I'm going to show you the basic mechanism of it. So I'm going to start to increase my voltage from the power supply. And you can see at about 30 volts I'm starting to get the vent fan to turn. And as I increase the voltage, you can see the voltage on the vent fan, again the red meter on the right, going up. And you might be able to start hearing the vent fan run a little bit more. Okay, right now I've got about 70 volts on the fan, showing about 40 volts across the capacitor in series, but notice that I'm only applying 43 volts or 44 volts to the entire circuit. As I increase the voltage on the entire system, you can hear the fan coming up in speed. It's now about 105, 106 volts on the fan, a little under 70 volts on the capacitor, and 58 volts coming from the power supply. Everything still is working well. As I start to increase the voltage just a little bit, all of a sudden you hear the fan increase in speed because the voltage went up to 140, but the voltage across the capacitor went up to 139 or 140 as well. So both of these are operating over the rated voltage of the fan, but notice that the supply voltage is still sitting at 58 volts. I didn't increase the voltage that much, but all of a sudden we got into a situation where there's energy being transferred back and forth between the capacitor and the vent fan. I'll back the voltage down just a little bit. And you can see all of a sudden everything goes back to normal. The capacitor's got 63 volts across it. The motor's got about 100 volts across it. And notice that the voltage from the supply really didn't change that much. I'm still sitting at 58. But you hit a certain point, and it's really not something we can calculate. And all of a sudden, the capacitor and motor start transferring energy back and forth. And if this was a real situation with a pad mount transformer and underground feeders, we could exceed the voltage on those underground feeders, and at some point we might see a failure on that as well. And this would all come about because one of the overcurrent devices had tripped open on the three-phase feeder. So again, a demonstration of series resonance.